wing, and the first thing I'm gonna do is glue the slats shut. I will not be using slats on this. That way I save 2 servos and I can keep the airplane light. So I just slathered on some epoxy, some air epoxy A00NS, and we're gonna seal that shut. So I have closed up the slat, and as you can see, it's still a little bit wet here, but I wiped the top of this with alcohol, which is how you get rid of epoxy. On this jet though, careful of the weathering, because that will come off with alcohol, so I gotta stay clear of those. But the epoxy that I'm using here should be cured in about 24 hours, but it's gonna harden in about 10 minutes. It's 5-10 minute epoxy, so we're gonna let that dry, and that way we'll have a nice stiff leading edge on this plane, and that's much lighter. On the flap, and the first thing is to kind of eyeball, sort of, you can see that hole there. Look from the inside. I look from the inside and eyeball sort of where that matches with the servo cover. And to do that, what I basically do is look at the wing, and you can see, let's see if you can see the hole right there, right to the left of the tape, and so that's roughly the estimation that I'm going to use. So the edge of the tape here is where I would like that linkage that's going to go to the flap to pass through. So once we have that, we're going to transfer that measurement onto this. Basically, I'm going to cover it up like this, and then we're going to mark the edges, so right here and right here, and that's where we're going to line up our servo at. We're going to build the crate that's going to hold the servo, and in the wing pack, which is labeled for you, you get 2 sets of each of these. So these are for the slat servos. I'm not going to be using slats on this, just going to eliminate the weight for that and all the complication. And this guy here is what you'll use to build the holder for the flap servo. So we'll take that off and I'll show you what that looks like. Alright, so once we've taken those apart, the way this sits is that you can see I have marked my cover here. So this side goes towards the leading edge of the servo, of the wing, sorry. And let's zoom out here, so you can see that. And so that's the trailing edge of the wing. So leading edge is gonna go like that. And obviously our linkage, as we mentioned, is gonna be going along this line back to the flap control surface. So what's gonna happen is that on the mounting boxes, basically the servo is gonna be mounted sort of in that fashion, like that. So the leading edge, the taller side here, goes on towards the leading edge of the cover. And basically we have that, and then you have these 2 pieces, right? Obviously different sizes, and that's because the taller side will go right there, sit just like that. So that is a side view. I guess take it off. We'll sit like this, and then the other one will sit on the other side like that. So we're going to glue these together, and then I'll show you the end result. So here's a piece. It's been assembled roughly just with CA. Obviously once I figure out the placement, because according to the manual, you want the linkage between the servo arm and the actual flap to be 103 millimeters long, which means that the spline goes towards the furthest away from the flap surface, so the leading edge of the wing. But the question is where to place this. So what I'm going to do is I'm going to attach my servo horn, and then again remember that this first line here is where I want the linkage to go through. and I drew the second one because this is where I think the servo box is gonna have to line up, maybe probably a little bit behind that, so that the arm lines up exactly perfectly perpendicular with that line. Okay, so here's the servo arm that CARF recommends, and basically the distance between the mount point and the horn where the servo is going to mount is roughly, I don't know, 9 millimeters, and this whole thing here, they want it to be no bigger than 14 millimeters. So we will set that up, and we'll see what happens. And you'll see that the reason for that is, see if I just mount this sort of like that, and on the arm there, and on the servo, actually, sorry, this goes like this. Yeah. So because this is the cover, and when you mount it, you're gonna invert it inside out, and you can see that the servo is not too much deeper than the thickness. The pocket here is not much deeper than the thickness of the servo with the mount in it. So if you make this too long, then the skin of the wing is gonna be right around here, and you will just scratch the bottom of the wing, or the top of the wing in this case. So by making this nice and tiny, then we can get it to fit in the wing surface just fine. So I have just tacked the servo box in place for now, and basically my measurement from this edge to this point where the servo horn is about 30 millimeters. Pretty much in the middle. If you put this box in the middle with, say, 7 millimeters on this side, 7 millimeters on this side, it kind of sits there nicely. And then in terms of the lining up, you can see what that looks like. So I have my spline just a little bit inward, because I'm gonna use a ball link on this side as opposed to a clevis. If I did a clevis, this would sit right on top of that, but that's where I'm at. So I'm gonna test fit everything, and then if I like it, I wouldn't glue it permanently, otherwise adjust. For the mounting, this is what that looked like, and as you can see, I'm using these Bluebird BLS servos, and they came with very nice mounting hardware, so that's what I'm going to use. Basically lock nuts on the back side and machine screws with washers on the front. So yeah, so we're going to test fit this, make sure that our alignment kind of looks okay, and then once that's done, we're actually gonna add the linkage and everything before we finalize and epoxy this piece of wood to the plate. Back at the flap. So right here, what I have is a flap fully bent out, and you can see that it comes with a tiny slot. I prefer to have a much wider slot so that everything can just move freely. So I'm going to be cutting out what's inside that square so that I have enough room for my linkage to move through. This is what comes in the packet. So you have an M3 rod in there, you have your clevis, nut, brass rod to make sure that that's nice and stiff, and as I mentioned earlier, in my case, I'm going to be using a ball link inside on the servo, and that's just because I was able to drill and tap an M3, and that's going to be really good for that to just be screwed in there with Loctite. So that's what I'm going to use. That has been widened. Next thing I'm going to do is, as you can see, I have a Sharpie mark here, and what's behind there is the actual horn. And the reason I need to gouge this out is because when I install the push rod in there, because it's a clevis on this side, it's very difficult to get at that horn from outside here, because when the servo's in there, it actually wants to pull this horn further in, so the horn will kind of sit, say, somewhere like, say, right there, and it's just really hard to push this flap in and try to get that clevis into the horn without this cutout. So that's what I'm going to do right now. So the clevis is in, and now we're going to worry about the other process. And here you can see why I needed, or I wanted that square hole cutout, because now my linkage has a lot more room to move around and it's not going to contact anything. Right here you can see why it was important to mark that line, because now it is perfectly aligned with exactly where the servo is gonna line up. So that's why it was important to mark, you know, the angle and get the geometry right for that servo horn. I'm finally happy with the flap, and the manual calls for measuring the outer deflection, the deflection at the outside chord, to be about 50 millimeters or max. And what I'm able to do is get about 56 millimeters, and I can get even more. But what's interesting here is how I designed this. So with a linkage of 108 millimeters driving this, and a servo horn distance from the spline to the hole of about 8 to 9 millimeters, then you get this range whereby at about 2000 PWM, your flap is at the angle that you want here, and then at about 1000 or so PWM, you can see about 1061 or thereabout, the servo is pretty much level. So that tells me that I'm getting pretty good range, so almost 1000 microseconds of PWM signal, so that's good. So I'm happy with that design there. And these servos are pretty good, like it's not going anywhere. Alright, so here's the flap linkage. What I want to show here is that to get that full deflection on the flap of about 50 or so millimeters, you're gonna need a linkage that's about 108, almost 109 millimeters long. And like I mentioned earlier, the servo horn is quite tiny. I think it's about 8 or 9 millimeters. Yeah, there you go. And you don't want it any longer than this, because the way this sits, if you make the linkage too long, the geometry doesn't work out. You find that this rubs up against the ridge just before it contacts flap. So you want this pretty much sitting up and nice and short. So we are done with the wing, and this was a final touch, which is to get the AR connector installed, and obviously snakeskin to protect the wires from chafing against the wooden formats here. So we are going to create, I guess, create the harness that goes on the fuselage side, and 3D printed these holders, and they work great. And so we're going to use that to secure these onto the fuselage, and we'll show that process, and then pretty much our wings will be done. I flipped the jet here to show how the wiring for the flap is done. So there's the connector. You can see it just goes right through there, through the former work, goes through right here, and then gets routed into the rest of the fuselage. So with this plane, you kind of have to build it either upside down, as you see right here, or on its gear. So that's why the gear is extended, and I have this platform here with my chucks for the gear. Otherwise, this is soft. You don't want to set the plane on a stand on these. They're not designed to take the load. The other thing I'll show while I'm here is the turbine wiring. So I am creating the harness for the turbine and letting it hang in there. I also have the harness for the afterburner LEDs that are in here. I'm making my own incarnation, and you can see them in there. So that's where I'm at right now. When you're putting in your wings, and I didn't see this in the manual, the spars are labeled. You can see that says R, and I suspect the reason for that is these screws right here, these threads. So these threads are where your wing is going to get mounted to, and that's going to get secured using these M3 screws. So when the wing is getting inserted, we just have to make sure that we get the correct rod and size positioned, and then the wings on the bottom will have a spot for them to, so those screws to screw into there. So we're on the bottom of the wing, and here are the two screws that hold the wing in place to the spar. So there's one there and there's one here, and that was a really tight fit. So I guess that's good because it keeps everything tight, but it was really a pain in the butt to get in there. And with that, the wing is mounted.